Hi, this is a supplementary math lesson for Algebra 1, lesson 85A in your textbook. And I would like you to read over that section in your textbook starting on page 303, continuing on to page 304 in conjunction with this video. So we are looking at the equation of a line. And this is one of the things that you need to grasp in mathematics because it's everywhere out there in the real world as far as science, engineering, technology, and many other technical trades like construction on down the line. So this is a very important concept. Linear relationships, linear meaning in a line, a straight line, relationships are everywhere in the real world, and your ability to understand them and know what they mean and how to graph them, how to derive values from them can be very important in any career that you might want to take. So just real quick, we're going to kind of break this apart into 3 sections for the remainder of the week. There won't be a whole lot of homework. I just want you to get these concepts. So you need to get this concept down. Equation of a line, linear relationships. So we're going to take a little time going through it. So the book in this section identifies the general form of the equation of a line as this up here: y equals mx plus b. And that is something you need to memorize. And yeah, Ethan, I'm sure you are not a big fan of this, okay? It's bad enough they started putting letters into our math problems, okay? Now, they've gotten rid of the numbers altogether. We only have letters in there. Is this some kind of strange plot by the English studies establishment to take over the math section of school? I don't know, okay? But now we have all those letters in there, no numbers. Is this even math? Okay, well, not really. This is just a standard form. It's an example of what a line, the equation, excuse me, of a line should look like. And we've actually been expressing things in that form already. You know, when they give us ordered pairs, they might give us an equation like this. And so in order to establish the little graph of ordered pairs we do, remember that I said the first thing we do, well, let's go ahead and set it to y equals. So when we plug x into it, it already will equate to what the y coordinate should be. In other words, we want to get the y alone, okay? So we keep this 4y over here. We send the 8x over to the other side, becomes a positive. We send the 4 over to the other side, it becomes a negative. We divide out that 4. Y becomes 8 divided by 4 is 2x. Minus 4 divided by 4 becomes minus 1. Okay, then we can go ahead and set up our graph, little graph of ordered pairs. And we use minus 1, 0, and 1. Okay, so we plug minus 1 into there, we get minus 2 minus 1 becomes a minus 3. We plug 0 into there, it becomes 0 minus 1 is a minus 1. We plug 1 into there, and for x, it becomes 2 minus 1 is 1. We take that over to our graph, and we plot it. A minus 1, a minus 3. A 0, a minus 1. A 1 and a 1. Okay, we got 3 points. They look like they're lined up pretty good. And we go ahead and connect them with a line. Okay, and we notice it gives us a slanted line, a diagonal line. In mathematical jargon, we say a sloped line. Okay, so we notice in the general form, it's expressed as y equals. Here we have a y equals a number times x. Okay, that number we define as the slope. We'll get into the pieces parts of this in the follow-on lessons. This is just identifying the parts of the equation of the line. Okay, then we have plus or minus a constant, a number. We have that down here in -1. Okay, now the x and y remain in the equation. Those are our variables. And as remember, so what are the parts of the equation of the line? We said the x we call the independent variable. Okay, we can put anything in for x, and that's what we do over here. We identify the x points we're going to put in our ordered pairs first. We list those first. We can put anything in for x. It's up to us. Okay, y is the dependent variable. We can't go ahead and put anything in for y when we did that for x. Okay, the value for y depends. It's dependent on what we put in for x. Okay, so we must solve the equation to get the y. Okay, so x, the independent variable, y, the dependent variable, m is just a symbol for the slope. Okay, so in this equation down here, the slope would be what? It would be the number 2 right here. That is our slope. Okay, and the b in the equation represents the intercept. Okay, what we call this intercept, or sometimes they call the y-intercept. Okay, and what is our y-intercept in this equation down here? Okay, it is, we could say 1, but also we actually attach that that plus or minus the operation, the sign to that letter. So it would actually be -1 would be our intercept. Okay, so we've already done this. We've already been doing this. We just haven't attached the fancy name, the general form of the equation of a line. And we generally don't say that when we mean this format for a line. We just say the equation of a line, and it's assumed this would be the format that we put it in. Y equals the slope times the value times x plus or minus a constant. Okay, and that's what we have here. Okay, so those are our points of a line. Now we notice, and I mentioned this before, so we have 3 types of lines. Okay, we have perfectly horizontal, flat lines. We have perfectly vertical lines, up and down lines, and we have these slanted, diagonal lines, what we call sloped lines. Okay, now this general form of the equation of a line is applicable only to sloped lines, because we see in a true vertical or horizontal sense, this kind of approach's convention breaks down a little bit. It's kind of hard, and it's the same way. Think of it, when we did our ordered pairs, we tried to do ordered pairs with the equation of a line. Okay, I'll just do 2 points here. If our equation of the line is y equals 3, okay, we pick our values for x, we go ahead and try to substitute in for there, and what happens? There is no x value in this equation of the horizontal line to substitute in there to return a y value. Okay, and so it breaks down. It kind of that convention of using ordered pairs to plot the line breaks down. And it'd be the same case in this general form of the equation of the line. If we try to use this on a perfectly flat horizontal line, it'll break down. They'll get to a point where we'll be like, this doesn't make sense. I've got no x to substitute in there. Okay, and the same thing over here. If we try to put in coordinates for x and y, and I'll use -1 and 0 again. Okay, when I go ahead and substitute that in, okay, I'm going to substitute in x is -1, and then it will equal -2, and we'll be like, what in the world? -1 does not equal -2. Okay, that convention breaks down that method breaks down for plotting this equation using ordered pairs. It doesn't work. And it's the same thing here. If we try that on this general equation for a line, that will break down too. So you got to remember, and that's why we introduced the concept of vertical and horizontal lines. You have to kind of memorize, well, not kind of, you have to memorize the fact if we see an equation of a line as x equals a number or y equals a number by itself, there's only one variable in each. Okay, it's either going to be a vertical, perfectly vertical, straight up and down line, or a perfectly horizontal line. Okay, if the equation of a line has both variables in it, y and x to the first power, in other words, y to the first power, x to the first power, we recognize it's, and as we did before, it's a sloped, a slanted, a diagonal line. Okay, and actually this confirms when we rearrange that equation down here in the form that we did so we could solve for ordered pairs, it matches the general form of the equation of the line. So we've already been doing that. Okay, we're just attaching specific names to that equation now. And the follow-on videos for the rest of the week will be, well, these particular values or definitions will help us plot this equation of the line, or from a plot, it will help us determine the equation of the line without having to do all of this substituting in and doing ordered pairs. So it'll be a kind of a shortcut method. So that's big picture what we're doing. I hope this helps. So your homework today, watch this video. You have a couple questions to answer in an email that I sent to you. You can just type those out in written form and reply back on that email. That will be your homework assignment today. Okay, so remember, 3 equations of a line. We have 3 types of lines, and yeah, this is a danger of doing homework lessons at home in my basement where my kids stole my yardstick. I can't point, so I'm resorted to using this foam noodle to do it. We have horizontal lines, we have vertical lines, and we have sloped lines. Okay, and these are the pieces, parts of the general form of a sloped line. This equation only applicable to our sloped type of line. You have to recognize by inspection what a horizontal and a vertical line will be in equation form. Okay, so long for now.